Let's do a quick order of magnitude estimate. Let's find the approximate volume of water in Sydney Harbour. So the point is that often we want to know roughly what a quantity is, and it's often very difficult or impossible to guess. I don't think I could guess the volume of water in Sydney Harbour, but an estimate is not a guess. In an estimate, you take a bunch of guesses or estimates, but they're often guesses, that you have some confidence in, and you combine them into an estimate of something that you can't guess. And this is often called a Fermi problem. And the idea of a Fermi problem is that you just work in orders of magnitude. So we're going to come up with a simple model. So the simple model is the harbor will have some length, and it's got some width, and it's got some depth. And we can think of the volume as just the length times the width times the depth. Now, strictly speaking, that's only if it's box-shaped, which it certainly isn't. But this is only supposed to be a rough estimate anyway. So now, instead of trying to guess this whole volume, we can have a go at each of these quantities. So I'm going to start with the width because it's the easiest. If you're standing on the boardwalk in Sydney looking across at North Sydney, think about that distance. Think about the length of a football field, right? The length of a football field or a soccer field is about 100 meters, right? And that width is certainly quite a bit bigger than that. So it's certainly bigger than 100 meters. So do we think it's more like a kilometer or more like 10 kilometers? Which one? 1 kilometer, 10 kilometers? Well, a handy thing to know is that if you're just looking out across water or standing on flat land like in the prairies, the horizon is a little less than 5 kilometers away from you. And North Sydney is certainly not way off on the horizon when you're looking at it from the boardwalk in Sydney. So I think it's more like 1 kilometer rather than 10 kilometers. So that's what I'm going to say. I'm going to say the width is a kilometer. And I'll write that, I'm going to work all in meters because that's going to be easiest. So that's 10 to the 3 meters. Now the length. The length is actually not too difficult to estimate. If you think of starting in Sydney River and driving all the way up to the bend where it opens up near New Waterford, in good traffic, you can drive that in half an hour, and you'll probably be going maybe 50 or 60 kilometers the whole way. So, or on average. And so I'm going to guess that the length is maybe something like 20 kilometers. Okay, so I'll call that's 2 times 10 to the 4 meters. And by the way, some purists would say in a Fermi problem, you should stick to strict orders of magnitude. So I shouldn't say 20, I should just say 10. But I'm pretty sure it's more like 20 or even 30 than it is like 10. And so I'm going to stick with that. Okay, the depth is maybe a little harder, but it's certainly, right, that depth, well, it's certainly bigger than 1 meter. Okay, so is it 10 meters? Is it 100 meters? I don't think it's a kilometer. So I think it's down to 10 meters or 100 meters. Well, here's my reasoning. There are big ships that come in, but they've had to dredge to make it easier for big ships to come in. If the harbor was 100 meters deep on average, they would have no need to dredge. So I think it's more like 10 meters. There's my guess. Okay, and so there we go. We have our estimate. We can just multiply those together. 10 to the 3, 2 times 10 to the 3, 10 to the 7, 10 to the 8. 2 times 10 to the 8 cubic meters. There is my estimate. I've come up with this estimate of the volume of Sydney Harbour. It's 2 times 10 to the 8 cubic meters. And whenever you come up with any number in a calculation, you should always stop and take a moment to assess it. Now, if you can, compare it with things you know, right? So if you've found a speed, think about it. Compare it with speeds of, walking, driving, things like that. Here, well, you probably don't have much of a concept for volumes of harbors, and neither do I. And trying to look it up on the internet, you simply cannot find the volume of Sydney, Nova Scotia's harbor. But you can find the volume of Sydney, Australia's harbor. And it is apparently 562 million cubic meters, right? And so that's 5.62 times 10 to the 8 cubic meters. And so that's suggesting that this order of magnitude estimate probably has got us to the correct order of magnitude, because it's coming out to the same order of magnitude as another harbor. And Sydney's harbor, whichever one you mean, is pretty big. So they're probably comparable. Now, the other thing I just want to stress is that this is only an order of magnitude estimate. If we were to ask how many significant figures we have here, you might be tempted to say 1, right? You might be tempted to say, oh yeah, there's 1 sig fig. But that's really not true. Remember that this too came from my estimate of the length of the harbor as 20 kilometers. But, I estimated the width of the harbor as 1 kilometer. Well, it could be, in most places, closer to 2 easily, or even 3 out near the mouth. The depth I estimated very roughly to be 10 meters. Well, maybe a better estimate would have been 20 or 30 meters. So we really do not know this 2. It's probably not a 2. And so, in fact, an order of magnitude estimate generally you can think of as having 0 sig figs. All it has is the order of magnitude. Any number you have out in front of the order of magnitude really is no better than a guess.